Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm excited to have Tom Gurski with me, founder and CEO of Blue Dot Motorworks. We're going to be talking about the process of electrifying passenger vehicles, which is an important topic because those cars, trucks, vans, and SUVs on the road today account for around 10% of global CO2 emissions. Normally, when we think about addressing that problem, we talk about replacing existing gas-powered vehicles with new EVs or hybrids. But Tom and Blue Dot have a different approach. They have a hardware system that converts those existing gas cars into hybrid electrics. I personally love this because the reality is that replacing all those gas-powered vehicles on the road is going to take a long time. In the meantime, those cars are going to continue emitting a lot of CO2. Also, I don't personally have the numbers on this, but intuitively, it just feels super wasteful to scrap functional gas vehicles and replace them with something brand new, like a new EV. So I'm really excited to hear more about Tom's approach. To introduce Tom quickly, he is a former Synapster, which is a first for the show. So I was lucky enough to work with Tom on at least one big project at Synapse about a decade ago, and he made a really big impact on our company and his clients before leaving to pursue other things. Tom is the kind of engineer I hoped to become when I first chose that path in college. He is deeply technical and rigorous, but also has the big picture view to know where to apply his talents for positive impact. I have one short anecdote about Tom I'll share. This happened after he interviewed for the position at Synapse, and we were debriefing internally, and the interview team said that they had never seen someone crush the technical interview as thoroughly as Tom just had. And I know that that's a really, really high bar. From that moment, Tom, I've had immense respect for you, and that just continues to grow as I see what you do with your career. So I'm really happy to be talking to you. Thanks for making the time to be on the show.
No, thank you. Thank you so much. That's almost an embarrassing introduction. Thank you. Super happy to be here. This is fantastic.
Do you remember that interview?
I do remember that interview. Yeah. I'm not sure crush is the word I would have used, but I do remember it. Yeah.
Apparently it was quite the performance. So maybe before we get into EVs and what you're doing with Blue Dot, I think it's fun to reflect a little bit on our time together 10 years ago, because it was a pretty interesting project. The project we worked on together at Synapse was called the Fecal Sludge Omni Ingester, which is probably one of my favorite product names in the history of Synapse. I was wondering if you could...
Yeah, that's why we very quickly came up with our own project name, which was Rage Against the Latrine.
Rage Against the Latrine. Yeah, also a highlight. Yeah, could you explain what that was? I guess, do you remember the project?
Oh, of course. No, that was... And I'd say in general, my time at Synapse was fairly brief, but incredibly formative for the period that it was, both in terms of being such a cool place to work. And I'm definitely going to plagiarize a whole lot as I grow my own company about how to do things and make a company that's a great place to work.
Nice.
But certainly also that project. So just a little bit of background. There are literally billions of people in the world that don't have a safe sanitary place to poop. And this was part of the portfolio of the Bill and Melinda Gates Foundation trying to address that problem. And specifically the problem of what do you do with a latrine when it gets full and the people can't afford to have it emptied, or there's no good way to have it emptied. So this was a technology development around how to economically, safely empty full pit latrines, basically bring an on-site processor to the latrine, do a good chunk of the upfront processing on-site, and then ultimately transport a much smaller volume to a waste processing plant. Super interesting technically, super interesting impact-wise, and it hooked me on that sector. And I've been involved in that sector ever since, obviously scaled back as Blue Dot is ramped up, but definitely something I want to be participating in for the rest of my life.
Yeah, that's awesome. I saw that kind of snooping on your LinkedIn that you've continued to work in that space. Is the Fecal Sludge Omni Ingester in operation anywhere?
So not so much. So I think that project was perhaps a bit overly aggressive in how it was framed in terms of what the product requirements were. So we did some great technology development, but I'd say that kind of whole portfolio suffered a bit from shooting for Mars when the moon would be good enough. And so unfortunately, not all that much of it has been commercialized to date.
So you've dedicated your life and career to solving some pretty major issues in the world between sanitation and now what you're doing at Blue Dot on climate change. Was there a point in your career when you decided that's how you wanted to use your talents, or has that always been a driving motivation for you?
It's always been present and an influence on my decision making. So even just with trying to select my first job out of college, I went to work for Dean Kamen's engineering firm up in New Hampshire. So I was working on their Stirling cycle generator project, which had the potential to displace some much dirtier technologies. I would say for me, it kind of started out as impact being a nice to have. And then throughout the course of my career, it's grown from that to a need to have. That has to be everything. That has to be the main focus. So it's been an evolution.
And how do you choose where there's so many problems in the world, right? So many places you could have impact. How do you choose where to focus?
Well, so just continuing in that global sanitation space was an easy one because that's right on the bleeding edge of where big impact is needed. It aligns well with my skill set. And then I kind of already had that in with getting involved in that first project. So it was super obvious that I needed to stay involved in that space. Getting involved in climate tech, that happened as I was putting together my own consulting company after my time at Synapse. And, I certainly wanted my consulting work to focus on impact stuff, but I also just really wanted to build something from the ground up. And so how it came that I started working on this problem was a bit organic in that I've just always been a car guy. So I grew up wrenching on cars. I've done a bit of racing. It's just always been a part of my life. So I've just picked up a lot of technical information along the way just from being so dialed into that sector. But obviously, super passionate about climate change. So bringing those two together was the obvious choice. And as I was kind of thinking about what to do with that combination, kind of came down to two just big gaps that I see in the market. The one, obviously, is what Blue Dot became, and that's, shouldn't we be able to do something with all these existing cars? And then the other I considered was sort of a three-wheeled electric commuter vehicle, because those seem to be not super well represented in the market either. Ultimately, I decided the potential for impact was bigger with this approach. And had I known the technical challenges involved with, and beyond technical market and fundraising and all the challenges associated with this approach, maybe I would have chosen differently, but I'm quite glad that I did, because sort of going back and retroactively justifying that gut feel of wouldn't it be nice, it's become painfully obvious that the world needs a solution like ours, if not ours, somebody else's, but it needs a solution like ours. And we can certainly talk about why that's the case.
Yeah, I want to, but now you have me curious. Why a three-wheeled vehicle? Why is that important?
Well, it's important because a three-wheeled vehicle is considered a motorcycle in most countries. And so the regulatory environment is dramatically different than it is if you're making a car. So you can take a lot more liberties with a three-wheeled vehicle than you can with a vehicle. And the development and manufacturing process and whatnot is substantially streamlined. That, and there's just some innate efficiencies that come with making an extremely light kind of human scale vehicle that can have a big impact on emissions.
Gotcha. So that's where the climate change tie is. It's just much more efficient, better fuel economy.
Yeah, it would still be electric, but it would be a whole vehicle rather than a kit, as we like to refer to ours.
Okay, so you went the path of Blue Dot, and you're making this hardware kit that can install on existing gas vehicles, turn them into hybrid electric vehicles. Now that you've been in this, tell us why it is so painfully obvious that this is a problem that needs to be solved.
Yeah. So initially the gut feel was there's currently over 1 billion cars on the road. Seems like it's going to take a while to turn those over. And so I started doing some research on what exactly that fleet turnover is going to look like. And there's actually a pretty significant paucity of research that's been done on fleet turnover. A couple of groups, BCG included, have done some of the first part of that of, at our current rate of adoption, what is that fleet turnover going to look like? But nobody, as far as I can really tell, has gone the extra couple of steps of saying, all right, well, what are the climate and emissions implications of that kind of a rate of turnover? And then look at other scenarios, other ways to actually achieve the type of turnover that we need to achieve in order to align with climate targets. So that's what I've had to do, built basically a transient model of every year between now and 2100 and mining a bunch of existing data sets to say, what would that turnover look like in various adoption scenarios? And it's frankly terrifying. It's a really, really ugly scene. It all really just comes down to the fact that relative to the size of the fleet, our annual vehicle production is quite small. And that fleet is growing pretty dramatically. And that's due mostly to gentrification in historically lower income countries. So for every 3 cars you produce, you only take 2 off the road. So you combine just that mismatch in size and production with continued growth. And the turnover is just extremely, extremely slow. And it should be obvious just from kind of back of the envelope stuff. We're talking about phasing out new car production in the really aggressive scenarios by 2035.
New gas car production.
Yeah.
Yeah.
But a modern car lasts 21 years, and that's going to keep getting longer. So even if we're still producing a significant number of cars in 2035, gas cars in 2035, those are going to be on the road in 2055. And that's well past when we need to have hit net zero.
And even today, like you said, for every 2 new cars we're producing.
Every 3 cars we produce, we take 2 off the road.
Or sorry, for every 3, we take 2 off the road. So the total number of cars is increasing. And most of those cars are still gas, or what does that look like?
Oh, yeah. Dramatically, most of them are still gas.
Yeah. So, yeah.
In the US, we're kind of at, last number I saw, I think it was 7% of sales. That's gone up a bit maybe since the last data I saw, but the fleet is like 1%.
Mm-hmm.
So
okay.
People tend to confuse the production with the actual emissions impact, but the emissions impact comes from the fleet turnover, not from the production of the vehicles.
Right. So, and then even if we were to magically stop producing gas-powered cars today to ramp up production, I mean, it just feels like the numbers are just staggering to be able to ramp up.
They are. So I've looked at a whole bunch of different scenarios. And really, the few that really stand out are, if you consider kind of a vehicle production cycle to be about 10 years, you have 5 years of development, 5 years of production. If we were to just say 5 years from now, we're going to ramp down gas car production in the next 5 years and switch over to pure electric vehicles in that time frame, we still just blow right past any kind of 1.5 or 2C emissions budget, carbon budget. So it really doesn't matter how fast we make that transition. So that's quite terrifying. But the worst part is the next step that I took was, let's actually see what it would take to make that transition happen fast enough to hit our climate targets. So if we're talking about 1.5C, we would literally have to double the size of the automotive industry. We'd have to be producing twice as many cars as we are now to put enough EVs out there fast enough. And that growth would have to happen in years, not decades. So now that you're producing extra cars, you have to look at the cost of those extra cars. It would be somewhere on the order of $40 trillion worth of cars that we wouldn't have otherwise been producing. One trouble that I have, and I think we all have, is that when you talk about numbers on a global scale, they become kind of meaningless, right? What is $40 trillion on a global scale? So I kind of try to bring it back to something a little more tangible. And so if we look at how much we spent on the Apollo program as a fraction of GDP, and then we look at this $40 trillion number as a fraction of gross world product, this is about 12 times more relative spending than the Apollo moon program. And that's only to address vehicle emissions, which, like you said, for passenger vehicles, you're about 10% of global emissions. So yeah, there's really kind of five roadblocks that make it a completely untenable solution. One is that cost. The other is that battery production would have to increase almost 700% faster than what we're predicted to do to produce that many vehicles. We'd need like 3 million additional public chargers that wouldn't have been otherwise needed. And that's 99 years worth of installation at the rate we were going in 2019. And then because we're talking about extra vehicles, you got to make room for them. So you got to take cars off the road prematurely. And that just destruction in value is at least $11 trillion by my calculation, which is more wealth than the US lost in the 2008 financial crisis. So just a massive impact for the global economy to absorb. And then, of course, lastly, there's the embodied carbon problem. So we've really painted ourselves into a corner here with waiting so long to get serious about climate change, where we really have to consider what's the impact of our solutions as much as we have to consider the benefits. And so to produce that many extra cars, it's 18 gigatons or thereabout of extra carbon just from the production of those vehicles.
Gotcha. That maybe explain embodied carbon just as a concept. We haven't talked about that on the show.
Oh, sure. Yeah. So that's just the energy that goes into making something has a carbon impact, carbon emissions associated with it. So for most things, most physical products, at least, it boils down to the raw materials. So how much steel, how much glass, how much rubber and plastic are in it. And so you can pretty much do it on a weight basis. And based on, especially an electric car, the batteries themselves take a lot of energy to produce. If you're talking about a car that wouldn't have otherwise been produced, it takes about 8 years of driving to negate the carbon emissions from an electric car.
Okay.
I'm sorry, the embodied carbon of an electric car.
Right, the embodied carbon. So actually, it's not, we always think about cars on the road producing emissions, but even just the emissions associated with producing all the cars we're going to need to replace all the gas cars is a significant part of the problem.
Yeah, it's a big problem. Unfortunately, it does get a lot of bad press. People try to manipulate these numbers and say that, an electric car takes more carbon to produce, so therefore it's worse than a conventional car. And that's absolutely not true. If you're comparing apples to apples of somebody who's already in the market for a new car if it's going to be electric versus if it's going to be gas. Yes, you do pay a higher initial penalty with the electric car, but then the lifetime emissions are so much lower in use that it more than makes up for it. And in most situations, very quickly. It depends on how clean your grid is. It happens faster in Washington than it does in West Virginia. But it is, if you're talking about baseline being a new car is going to get bought, then absolutely electric is going to be better. But if you're talking about producing a car that wouldn't have otherwise been produced, that's a whole different scenario.
Okay. I was actually going to ask you if you could help me settle a conversation we're having at my house currently about whether we should buy a new EV or keep our existing 2012 SUV, I think it is. So you're saying if we're going to buy a new car, it should be an EV. But how do we decide between keeping our existing car? Like, at what point does it make more sense to buy a new EV?
Yeah, that gets quite tricky. So you have to kind of remove yourself from the situation and say, what would business as usual have been? What would we have done if we, let's say, we didn't have the option of an electric car? What would we be doing in that scenario? And then kind of make your decision based on that. We don't throw away a car when we buy a new one, right? We sell the existing car and that just moves down market. So buying a new EV doesn't reduce emissions. It's only when that results in an existing car getting pushed into a scrapyard that emissions are actually reduced. So that's kind of the mindset we have to take. And unfortunately, there's no clear-cut answer. You can't just say this is the best scenario. It's all incredibly situational. It depends a lot on how much you drive. If you don't drive very much, then you're never going to negate that initial embodied carbon penalty. If you live in West Virginia and your grid's really dirty that you're using to charge your car, then the payback happens a lot slower. So again, if you don't drive much, it makes a big difference. These kind of factors are one of the reasons why I, at the end of the day, don't think subsidies are really the right way to be stimulating the right behavior, because you can be subsidizing behavior that's actually having a negative impact compared to what you're trying to do. So I'm just, in general, a big carbon pricing fan.
Yeah, it's interesting because there's so much kind of positive marketing and everything around electric vehicles. And also, I know people who work at Tesla and these other EV companies, and they all want to do the right thing for the planet.
Yeah, and there's no question we need new EVs. In fact, when I first started crunching these numbers, I did get a little bit down on new EVs as a solution. And then I took this analysis that I had done and I kind of tried to make it work by doing kind of just retrofits and it doesn't work that way either. Like, we need to go all in on EV production as a replacement for new gas production. But we can't get there with that alone. We also need significant retrofits. And it turns out that to really kind of balance those negative barriers we talked about, the 5 of them, needs to happen in about equal numbers. We need to make about 1 retrofit for every new car that we sell for the next decade or so.
Well, so I guess in summary, it sounds like we're not getting there without it. From everything you've looked at and all the modeling you've done, and you're making a pretty convincing case that we're not going to get there to the carbon emission reductions we need to limit warming to 1.5 degrees without retrofit solutions. There's just no way the production industry is going to grow fast enough and we're going to be able to replace the fleet fast enough.
Yeah, that's my firm belief. It gets a little better when you start looking at 2C, but I'd still put it firmly in the realm of no freaking way.
Well, okay. So let's talk about how we get there. Actually, I'm curious, just kind of from a business model standpoint, what you're thinking. So let's say, my wife and I are looking at doing this, are looking at kind of retooling the fleet, maybe going electric, maybe keeping our old car, trying to decide what to do. Would we be a target customer for Blue Dot in the future?
Oh, absolutely. Yeah.
Okay.
And that's sort of our whole approach has been trying to address the kind of critical weaknesses that have always existed in the retrofit space, the electric retrofit space, and that's cost effectiveness and scalability. So if you look at, retrofitting an existing car is nothing new. People have been doing it for decades, but pretty much every approach that's out there has been to design a system specifically for a particular car and kind of make it as integrated to that vehicle as possible. And the analogy I like to use is that's kind of like going to a tailor and having a custom suit made. Yeah, it's going to be nice. It's going to fit great. It's going to look great, but it's going to cost you $3,000. And it's going to take probably a month or so to get that product. We want to be the Men's Warehouse. We want to sell a suit in small, medium, large, extra large. And it's going to be $300 instead of $3,000. And you can walk out of it the same day. Out with it the same day. So that's kind of our approach, is to design systems that are universal. So we have essentially 2 product families that can cover almost any light duty vehicle out there. We can mass produce that hardware at huge quantities, achieve the lowest possible price. And then that installation process, because we're staying essentially as unintegrated from the vehicle as possible, that installation process is pretty simple, very easy to train. So we can leverage third parties and have this happening all over the country, all over the world, without having to erect our own brick and mortar everywhere we want to go.
Oh, cool. So I would take my car into a mechanic somewhere locally and they would install this?
Yep. So we're looking at partnering with some of the national franchises that have shops all over the place. But we also want to be an option for the independent mechanics. That's going to be, the electric transition is going to be very hard on them. And we want to be able to provide a new revenue stream for them. So there's actually an organization that's going to be launching soon that we'll be partnering with. Their goal is to train existing mechanics to help them make that transition to the electric future. And we're going to try to partner with them to make installations part of what happens is with their programs.
Oh, cool. And then once I have this installed, what's it like to drive? How do I switch between electric and gas modes?
Just to clarify, we're essentially turning the car into a plug-in hybrid, which is a bit different than a traditional hybrid. The big difference being that we have much larger battery pack than a traditional hybrid would. And so it allows you to run on pure electric power for a given number of miles per charge. So we're targeting kind of 30 to 35 per charge. And that gives most people enough range to do almost all their daily driving, their daily commute, their runs to the shops, whatnot, on electric power. But we leave the conventional drivetrain in there. We don't take it out. So now when you need to do that road trip or go to grandma's or you forgot to charge or there's a big line at the charger because it's a holiday weekend, you can still rely on that gas engine. So it's critical in that plug-in hybrids make the most of our limited battery resources because you get about 60 to 80% of the benefit for generally about 20% of the battery. And then they're completely non-reliant on charging infrastructure, public charging infrastructure. So we don't have to solve that chicken and egg problem of which has to come first.
Oh, cool. So
from a user perspective, the way it would work, you'd get in your car, you'd put the key in, turn the ignition on, put the car in neutral, turn our system on via a desktop interface, select forward, and then off you go. And we have an auxiliary throttle pedal that gets mounted on top of the existing vehicle's gas pedal. And so you're basically using that to control the output of the system when you're in electric mode. And then you can switch back and forth between modes, again, with that desktop interface, and you can do it on the fly. But generally, most people will just run in electric mode until their battery's depleted. And then if you have to go further, you fire up your engine and keep going.
Sounds pretty slick.
Yeah, it's one of the main challenges with trying to do this universal approach is making the user experience acceptable. It would be easy to do it in a way that I would find acceptable as a very tech-savvy engineer who likes to get my hands dirty, but to do it in a way that would be acceptable to the mass market is one of the big challenges.
Mm-hmm. And then what about selling to, I don't know, I'm picturing like fleets of smaller vehicles that are for delivery or something like that. Is that a target as well?
That actually is our first target. So we're going to go after fleets initially and then enter the consumer market. Where we're getting the most traction is with municipalities, specifically ones that have emissions mandates or targets that they're trying to hit, and being highly budget constrained, have really no way to turn their fleets over fast enough to align with them. So that's our initial target. We also want to look at commercial fleets, higher education, campus fleets for groundskeeping and whatnot. And then we want to enter the consumer market.
And what's motivating those fleet customers? Are they looking at it purely, is there financial gain? Are they getting pressure to reduce emissions? What's the motivation there?
So in some cases, it's legislated. It's they legally have to hit an emissions target or an electrification target or whatnot. In some cases, it's financially motivated. And our approach is so intrinsically cost effective that you really, unless you're already in the market for a new car, you really can't do better from a return on investment standpoint. And then what we learned, interestingly, was talking to some fleet management companies, was that they're hearing from their customers that they're very interested in electrification, but it's not for the reason that I thought. I thought it was the positive PR that comes from decarbonizing your brand and all that. But for at least from what this fleet management company was saying, what they're hearing is that the main motivation is that these companies don't want to get dropped from investment portfolios. And the portfolios are having requirements on ESG.
Oh.
And they're worried they're going to get dropped from investment portfolios. And as we all know, businesses are run these days more for stock price than they are for profits. So that's a big deal for them.
Oh, wow. Okay. Well, so that's having a positive impact then, at least.
Mm-hmm. Yeah, kind of the tail wagging the dog, but at least it's heading in the right direction.
Yeah. And then I imagine, and you and I talked about this a little bit the other day when we chatted, but I imagine you could look at, it depends on where you kind of draw the scope of what your impact is. So if they're considering embodied carbon when they're thinking about whether they should buy EVs or do something like this is clearly the right decision. But if they're just looking at kind of the operational emissions of their fleet, it's not as clear. Is that right?
That's very clear. Unfortunately, the trend is heading in the right direction. So life cycle analyses are becoming more common, and that's becoming the standard in a lot more places versus just usage or tailpipe emissions, whatever you want to call it. And so that's where we really, really shine, is that we're so carbon efficient, we're so resource efficient when it comes to batteries. And honestly, if you're doing a full life cycle analysis and you're replacing a car that wouldn't have otherwise been replaced, you do have to consider the downstream emissions of that existing car. So yeah, we really, really shine in an LCA type scenario.
Yeah, awesome. What does it cost?
So like I said, we'll kind of be small, medium, large, extra large at the low end. For a smaller car, we think we can retail for somewhere in the $6,000 ballpark.
Wow.
When you start to get up to your pickup trucks, you might be $7,000, $8,000. You get to your heavy duty pickup trucks, you might be pushing $10,000. It's hard to say with prices being so volatile right now where exactly we're going to land. We still have a lot of development work to do to really sharpen that pencil, but there's really no reason why we shouldn't be comparable to the difference in price between a conventional car and a plug-in hybrid when they're both offered on the same platform, because we're able to manufacture at similar volumes.
Wow.
With our approach. Yeah.
That's out the door price? Or like installed?
Well, installation would be extra, and that's going to depend a lot on geography. Like a shop in the Midwest might charge you $60 an hour. A shop on the coast might charge you $120 an hour. So it's a little hard to say without knowing the details, but we generally think we'll be able to be a same day installation under 8 hours of work. So
not a huge addition on top of that.
Yeah, not a huge addition. You can drop it off in the morning and pick it up in the evening kind of scenario.
Wow. Yeah. I mean, looking at what, 70 to 100K for a new EV.
Yeah. And the real surprising hole in the market right now is that you can't buy a plug-in hybrid pickup truck. And that's pretty crazy. So like I said, we have two product families, and the first one that we're launching with, we call it the Narwhal. It's for vehicles that have a solid rear axle. So that's going to be predominantly pickup trucks and almost every single pickup truck. And that plug-in hybrid use case just works so well for a pickup truck, because most people, they have one car, they drive their pickup truck to work, they drive to the grocery store, getting horrible gas mileage. But they do occasionally tow their boat or their camper, or they load it up full of mountain bikes and go up to the hills. And that's where, especially when you're towing, an electric truck is a bit of a tough sell. You really pretty much cut your range in half when you're towing something. And a lot of especially lifestyle pickup truck owners, they're heading out to the wilderness where there's no charging infrastructure. So to me, it just blows my mind that there's no plug-in hybrid pickup truck on the market.
Oh, wow. So it's actually adding a category that there isn't even an alternative for today. Yeah.
Exactly.
Cool.
And then with that product architecture, we have the additional benefit of we can actually use the vehicle as a generator, because our system we can decouple the drivetrain of the vehicle and use the vehicle's engine to drive the electric motor, and use that as a generator to provide power for a job site or a campsite or for home backup power. So that's a pretty cool additional benefit.
That's pretty sweet. So you're kind of gearing up to raise a seed round right now, right?
That's right. Yep.
What's your goal with that funding?
So we want to raise a total in the seed round of $3 million, and that would take us through our beta build. So we're onboarding beta customers right now. We've got a letter of intent from one municipality. We're in discussions with another municipality, and we should be having a letter of intent very soon from a university in British Columbia. So we need to bring on board about 3 or 4 more customers to fill out that beta build. So that's what the seed round is, to take us through that. We're going to break it into 2 tranches. So the first half or thereabouts will bring us through our alpha build, and then the second half will take us through beta.
I've been thinking about this from the investor's perspective a little bit. And I have a question, which is actually, I come across this in a number of the climate tech companies I've talked to, which is that your total addressable market is decreasing, right? The more people transition to electric vehicles and all of that. How do you look at that from a business standpoint? How do investors see that?
Yeah, I wish that were a problem, because then we wouldn't be necessary.
Right.
And I could go do something easier. But unfortunately, this is not a 10-year problem. It's not a 15-year problem. It's a 30, 40-year problem. And so the way we tend to look at it is all the conventional vehicles that are going to exist between now and 2050, what does that market size look like? And so if you look at vehicles that are out of warranty, that's generally what we're targeting. It's more for the perceived issue of warranty coverage than any actual risk, but we're targeting out of warranty vehicles that are driven kind of that plug-in hybrid use case where you're doing kind of 10, 20, 30, 40 miles a day. And then what does that addressable market look like? And specifically vehicles that are good candidates for conversion, it's multi-trillion dollars between now and 2050. So it is, by the strictest definition, a transitional technology, but it's transitional on the time scale of companies like Facebook that haven't even been around that long yet. So
there's plenty out there. There's plenty of opportunity. Yeah.
there's plenty out there. Yeah, for sure. And we'll definitely be diversifying our product offerings over that time period. In fact, so we've generated about 360 pages of patent material in this development effort. First patent issued last year. We have a new one, a second one pending. And a lot of that is actually adjacent technology. So it's still kind of decarbonizing existing vehicles, but going the other direction. So if you have an electric vehicle that's got a degraded battery, for example, or even just was manufactured with a small battery from the get-go, which is something we need to be doing, we have a way to add a range extending generator to that vehicle to turn the electric car into a plug-in hybrid. So you can either give it a second lease on life, or you can make it something that you only use it when you need it. So you could, manufacturers are having a really hard time selling an electric vehicle with less than 200 miles of range or so, even though you hardly ever need that, right? So if they had the ability to sell an electric vehicle with 80 or 100 miles of range, and then you have this add-on generator that you can just connect to it when you need to go to grandma's house, that's kind of the best of both worlds, because now you're not carrying that engine around with you when you don't need it, like you are with a traditional plug-in hybrid.
Oh, interesting.
Yeah, so that's a whole nother area of technology development that's on our horizon, but that we're not focusing on right now.
I like that, though, because it would make adoption of EVs. I mean, it would reduce the barrier to adopting EVs. If the batteries are smaller, they'd be cheaper. They'd also be more fit for purpose for the majority of their use.
Exactly. Yeah.
Yeah, that's interesting. Let's talk about the hardware itself. Can you describe just physically what it looks like and how it works?
Sure. So like I said, we have two product families. We call them the narwhal, which is the one we're focusing on first, and then the humpback. So got a bit of a cetacean theme going. The big component is the electronics module. So that has the battery pack, the motor inverter, the charger, battery management system, all of that. And so for a given vehicle, you have the option of either putting it inside the vehicle, so it could be in the bed of a pickup truck or in the cargo area of an SUV, or you can actually hang it on a trailer hitch receiver, which is great because you can get one of those for pretty much every car out there and makes it super seamless. We're using lithium iron phosphate batteries, which don't have the same kind of thermal runaway problems that your kind of traditional electric car batteries have, sort of intrinsically much, much, much safer. So it's okay to be external. That big module has to go in the vehicle somewhere or on the back of the vehicle. And then we have to put the power down. So we always drive the rear wheels of the vehicle. So that's where the split comes between the narwhal and the humpback. So with the narwhal, we're essentially installing a unit in the middle of the vehicle's drive shaft. So all drive shafts have a hollow tubular section to them, which is great because that's a common interface we can use. What we basically do is cut a section out of that, weld on two flanges, and then what we call a coaxial drive unit gets bolted into the middle of the drive shaft. So that contains the electric motors. And we're using axial flux motors, which have phenomenal power density, and we're stacking a few of them in series to get that long, skinny form factor that we need. So those feed a planetary transmission, which increases the torque to the level we need, and then feeds into a clutch. And so this clutch allows you to either connect the motors to the vehicle's differential and therefore drive the wheels with the electric motor, or you disconnect the electric motor and connect the engine back to the wheels. So that's for conventional operation, or we can do that generator mode where we're connecting the engine to the motor and can use it as a generator. So that whole system just sits in that drive shaft space. We provide reaction torque. So normally that would just want to spin. If you tried to turn the electric motor, that would just want to spin on its own and not actually drive you anywhere. So you have a linkage that connects to the vehicle's axle tubes that provides anti-rotation torque to that unit. And then we have an optional kind of, we call it a supplemental suspension system. So for some lighter duty vehicles, you might get a bit of suspension sag from having that big battery in there. And so we essentially added an additional helper spring that can restore your normal ride height.
Mm-hmm.
So that's the narwhal. The humpback is different in that we drive the wheels directly from the outside. So kind of the commonality that we're leveraging there are the lug nuts. So you basically take off the lug nuts that came with your car, you put ours on there, and they only come in a certain number of sizes and shapes, which is great. And then that allows you to connect half of a quick coupling to the outside of the wheels. And then we have two swing arms that come from a trailer hitch mounted unit. We have two swing arms that come down forward from that and connect to the outsides of the wheels and drive them from the outside.
We'll put some links up in the show notes so people can see it. It's pretty impressive kind of how tight a package it is. And especially like the narwhal. I mean, like in a pickup truck, it just kind of sits right in the bed of the truck, right? Or
yeah, it just kind of looks like you got a toolbox back there.
Yeah, it's pretty slick how integrated it is and how kind of tight the package is.
Yeah, and so we're really, this probably wouldn't have been possible 10 years ago with where battery technology was. And so this is a good time to be trying to do this with all the advancements that have been made.
So what has the development process been like? Did you know this was kind of the concept from the beginning, or did you iterate at the concept stage?
Oh, I've done quite a few iterations. So I actually started with an electric pusher trailer type concept, and and there were I had some innovations there around making it really, really short, only have the thing be 1.5 feet long, and then have it be self-steering, so you don't have to use that crazy backing up a trailer technique whenever you're trying to back into a parking spot. But I pretty quickly rejected that concept just based on you're essentially towing the vehicle in reverse. So your towing capacity has to be greater than your vehicle's gross vehicle weight. And that's generally not the case. So I was worried there'd be structural issues with essentially towing in reverse and a few other issues around that I think make it a non-starter just from first principles. But then I quickly kind of translated to, all right, we got to drive the vehicle's wheels themselves. How do we do that in a way that we can achieve in a vehicle agnostic way? And it was actually the humpback was the first concept that I came up with. So I made that first prototype. I had a single motor with the differential in the back, put the battery pack in the back of the Jeep, and then had those two swing arms connecting to those special lug nut couplings that I mentioned. And it was really, I just had no idea if this thing was going to work or not. The first time I went to use it, it was such a far out there concept. So I literally drove to a forest road in Washington in the foothills of the Cascades. And when no one was looking, connected this thing up and tried to drive it for the first time. And it just worked. It just worked seamlessly. I couldn't believe it. I literally was laughing out loud. It was just, holy crap, this actually works. There's something here. This could be a real thing. And so it's been a refinement since then. And then the kind of big split that happened was then kind of realizing that, hey, a lot of cars out there have this solid axle configuration and they're all laid out pretty much the same way. Like there's some real commonality there. What can we leverage? And that's where the narwhal concept took shape. And so that's what I've been focusing on ever since.
Because you could do the humpback with a solid axle, solid rear axle.
You could.
The narwhal is a more kind of elegant solution.
Definitely more elegant. And it gives you that. One of the key benefits of it is that it makes it really easy to disconnect the vehicle's transmission when you're driving under electric power. So with some vehicles with the humpback, you might need to use an auxiliary electric pump to lubricate the automatic transmission. That's kind of a known quantity that those products already exist for people that tow their vehicles, especially behind RVs. But to not have to worry about that or deal with that is a real advantage of the narwhal.
What were you worried about failing when you did your first one? What was the risk?
I kind of thought I would just hear a big bang and a crash and I'd get out and there'd just be a tangled mess of garbage on the back of my car and maybe including my car itself. I thought it might be completely unwieldy to control, that I might just drive off a cliff because I wouldn't know what I was doing. That was before I even had as good of a control system as I have now. I was actually using a kind of a joystick type control in that first prototype. But even that was super easy to control. I've put a bunch of completely non-technical people behind the wheel and nobody said anything, but yeah, that's actually really easy, surprisingly easy to control. So yeah, those were the big things. Am I missing something about how all these forces and torques are going to get resolved? Am I missing how hard this is going to be to use? But kind of right off the bat, it was no, these are non-issues. It just works.
I was going to ask how many cars you've totaled in the process.
Yeah, no, my trusty Jeep has been our faithful test mule the whole time. Yeah.
That's awesome. And have you been, this is a pretty complex piece of kit. How much of a team have you had?
On the technical side, it's been just me the whole time. So in the first few years, kind of going back to 2015 or so, it was sort of working on this when the consulting work was light, making hay when the sun was shining, when the consulting work was heavy. And then really around 2019, since about then, I've been pretty much focused on this full time and just doing a few kind of passion projects on the consulting side. It's being just me and being extremely budget constrained. I'm basically using the consulting work to fund the Blue Dot development. It's been slower development than I would like just because I'm in my own machine shop making a lot of these parts and welding a lot of things together myself. And that's not my real gig, so I'm not that great at it. And so it takes me a while to make all that stuff come together. But it's been a great way to stretch the limited budget and be scrappy. But yeah, looking forward to having a real team again.
Yeah, my hat is off to you. That's really impressive to do all that on your own.
No, thanks. It's fun too, but
yeah,
just a little slower than we'd like to be going.
From a hardware standpoint, what have been the biggest challenges you've had to face?
Well, certainly achieving that universality, that vehicle agnosticism is the biggest challenge. That's so key to cost effectiveness and scalability that I really haven't allowed myself any wiggle room on that. Anytime I wanted to go out and kind of measure something on the Jeep to design a part around, I have to say that might be different on another car. I can't just use that measurement. I got to build adjustability into this system so that if it's 3 inches, it still works. If it's 6 inches, it works. If it's 9 inches, it works. So that's by far been the biggest challenge, with the caveat of while maintaining a positive user experience. If you throw that out the door, then it becomes a lot easier. But for a mass market, it's got to be pretty seamless.
Mm-hmm. Are all the dimensions of these things available publicly so that you're going to be able to integrate all these different cars? No.
I've had to make some educated guesses about just like what range do I need to accommodate. And fortunately, I am such a car nut and always have been. I can make pretty reasonable estimates and overshoot the mark, where in most cases, the architecture that we've developed is quite flexible and pretty easy to adapt. And we'll offer some parts in kind of small, medium, large again. So it won't necessarily be a 100% unique set of hardware, but a 90% unique set of hardware that goes into these.
And then looking forward, I mean, we've talked about kind of the numbers. There's just a massive quantity of these needed to make the impact you're looking to make. What do you see the challenges being getting to that kind of scale from a hardware standpoint?
Yeah, so convincing investors that the market will accept the solution is probably the number one barrier. It is essentially trying to define a new market, kind of in the way the Model T did in the early 1900s. Before that, an automobile was an extremely expensive toy for the ultra wealthy. And it was Henry Ford's manufacturing innovations that enabled him to leverage mass production to make automobiles accessible to essentially the middle class. And so that's really what we're trying to do with these retrofit approach and the universal approach, is to make retrofits accessible to the middle class by leveraging mass production. But there's no guarantee that the market will accept it. So what we have working in our favor is that the world is increasingly valuing decarbonization technologies and approaches and whatnot. And so it's not too much of a stretch to think that something like the existing federal EV rebate program will be able to get that to apply to our products, in which case we'd be essentially giving them away for free. That's just how intrinsically cost effective they are. So absent that happening, we can leverage the carbon markets. So especially in the compliance markets, based on current carbon pricing, we can offset the majority of the cost of the units through carbon pricing. How we actually leverage that, we're still working out the details of it. But you can imagine a scenario where we would kind of front the carbon credit, lifetime carbon credit generation value to the customer, sell it to them at a significant discount, and then we'll collect the credit as a revenue stream. That's sort of what we're looking at.
Sorry, I'm embarrassed to say I don't actually know how that works. Is this something like individuals can take advantage of carbon credits?
Yes. Yeah. It's an extremely complicated world and kind of divides into two worlds. You have the voluntary carbon market and you have the compliance market. So in states and countries that have cap and trade systems, then if you're emitting more than you're allowed to,
Gotcha.
You can buy credits to offset that. So basically, we're somebody else that's doing either avoided emissions or carbon removal, you can take advantage of their efforts. And when it's regulated that way as a legislated thing, the carbon value is quite high. The voluntary market, it's much, much more loosey-goosey space. So the carbon value price is a lot lower.
Mm-hmm. That is not in place in the US anywhere.
States have it in place. States have compliance markets in place. So Washington actually just kicked theirs off the beginning of this year. California has one. New York has one. I believe New York has one, or it's coming. Oregon has one. And a lot of states are considering them. So it's basically in lieu of just straight up carbon pricing, which in my opinion is the way we should be doing things. If it's done on a revenue neutral way, and you couple it with some government-backed loans so that people don't have to make out-of-pocket purchases that they can't afford. To me, that's the way to do it. But that's just been politically untenable to this point. So in lieu of that, these carbon markets are cropping up and more states are considering them.
Looking at the future, what do you see Blue Dot looking like in 10, 15 years?
Great question. So if we do our commercial launch kind of on the order of 2.5 years after we conclude this fundraising round, our commercial production launch. So we'll have been in the market 7 years or so. I think by that point, it won't be an unusual thing to see a car driving by with one of these systems on it. We're launching in the US, but when you look at the situation in low-income countries, there's really no other option. I mean, it's going to take decades for the used EV market to reach those markets. They're extremely cost sensitive. And fortunately, we may actually be able to leverage those markets with global carbon credits, especially after I forget what it's called, Section 6 from the Paris Climate Accords, essentially sets up the world to be able to do global carbon credit trading. So we might be able to have a really big impact there sooner than later, which would be great.
Well, maybe that's a good transition to the last few questions. How optimistic or pessimistic are you about the future of our planet and why?
Yeah, I struggle with my level of optimism quite a bit. I'm pretty optimistic by nature, but I'm also definitely an evidence-based thinker. And so far, I haven't seen any evidence of the really large-scale industrial shift that's going to be required to achieve our climate goals. I mean, there's no question we're going to decarbonize. We're going to run out of oil eventually, and we'll probably decarbonize ahead of that. But the only question that matters is how long is it going to take and what time frame is it going to happen on. And it's having crunched the numbers for the automotive industry, it's a World War II level of industrial mobilization that has to happen. And so far, I'm not seeing that. It's why that's the case. I mean, fundamentally, our economic system is pretty incompatible with that kind of a mobilization. And as we all know, our political system is essentially subservient to our economic system at this point. So that's my reasons for pessimism. But there's also a generational change happening in our political system. And if we can wrest control back, make sure our political system's serving the people on the planet, and if that can happen in the next few years, then we have a shot. But I think that's what we have to see happen first.
Mm-hmm. Good measured view of it. Who is one other company or person doing something to address climate change that's inspiring you?
Yeah, there's a fellow here in Washington, Jim Conca. I've seen him speak a few times, and I've got a very sensitive bullshit meter, and I'm not sure I've ever heard anybody talk about climate for probably cumulative 3 or 4 hours now, and it just never went off because everything he speaks is just good sense. So he has a nuclear background, but he's a very, very multidimensional thinker, looks at the larger societal view, and was certainly convincing enough to make me a huge advocate of nuclear power as a necessary component of achieving our climate targets. Introduced me to a few concepts that I wasn't all that aware of. This idea that it takes essentially 3,000 kilowatt hours per year for a person to not live in poverty. And we're really ethically obligated to do everything we can to provide that to the billions of people that don't have that. And so that means that we have to be able to achieve these climate targets in increasing energy demand environment, which just makes the problem all that much harder. And then, of course, there's the resource efficiency aspect of it. If you look at all the steel it takes to install solar and all the cement that it takes to install wind, there's just no way we can move on the time frame that we need to without incorporating something like nuclear in a pretty big way.
Cool. I have not heard of him. I'm going to look him up.
Yeah.
And I keep hearing people talk about nuclear. I'd love to do a show on it. Very fascinating topic.
Yeah, and I was pretty skeptical even fairly recently, but when you put the real issues down and start attaching numbers to them and just realize how many misconceptions there are and how much false information there is, it really changes your thinking.
What advice do you have for someone who isn't working in climate today, but wants to do something to help?
The one thing I always say is that you don't have to be somebody who works in or has a skill set that's like on that point of the spear when it comes to climate tech. Anybody can get involved and can help. And really the easiest way to do that is to just realize that all these organizations that are doing climate work, they need all the normal stuff that organizations need. So you can be an accountant, you can work in grounds, you can work in custodial, like it doesn't matter. Like all these organizations need all the normal organizational things. So just find one that's aligned with where you think we should be going and just help that organization.
I like that. Tom, that was really fun. Thanks for taking the time to chat.
Yeah, no, great chatting. This was a lot of fun.
Yeah, all right. I love what you're doing. I'm excited to keep an eye on Blue Dot as you guys grow.
Thanks so much. I appreciate the opportunity to talk with you.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.